This type of diagram is called a subsystems diagram. Right? They all follow the same general pattern. This one has got feedback control. Right? The output from the system is heat. We're measuring the heat using the temperature sensor so that the information from the output is being fed back into the start. So this has got a feedback loop in it. Okay. Other systems don't have feedback loops, open loop control, so that part there won't exist. Okay. So they're measuring the output, it's got feedback control. The operator sets the temperature that they want to be in the room or wherever it is. That gets fed to the control unit. The control unit then compares the temperature you want with the temperature you've actually got in the room. So the control unit will decide whether to switch on the system or not. So if it's cold, the output driver gets switched on by the control unit. The output driver acts as an amplifier. It could be a transistor or a transistor and a relay. So that's then able to drive the output. Okay, a relay could switch on a 240 volt heater quite simply. So then the output's monitored continuously so the temperature won't get higher than what you want. Okay, so the output driver acts as an amplifier to amplify the signal so it's big enough to drive the output. The dashed line around about is the system's boundary. Information passes into the system from the operator, and then heat passes out of the system into the room or wherever the heater is. Okay? And within the boundary is the system itself. Okay, so the control unit, the output driver, and the heater, and the temperature sensor, that's your system. Temperature comes in, the set temperature comes in, and the heat goes out. Right. This system puts a brake on when it gets too windy. Right. So how the system works. The operator sets the maximum safe wind speed, and that goes into the control. The wind is measured by a wind speed sensor, and that signal is fed into the control. The control will decide if it's too windy to switch on the output driver. The output driver will amplify the signal from the control unit and switch on the brake if needed, and the output is a braking force. This is an example of an open loop system. The wind that's been measured, it's not measuring the output force, it's measuring something else. There's no loop going back in. This is open loop control. Okay? The previous one had a loop going back from the output. The previous one was closed loop control. This one is open loop control. Open loop, there is no loop.